Hello students. Let's start revision of solution chapter. And here is the question. Question asked is one molar aqueous solution of the chloroacetic acid is heated to its boiling point. The solution has a boiling point of 100.18 degrees Celsius. Calculate the Vent-Off factor. So formula. Like this question is based on a elevation in the boiling point. This question is based on one of the colligative property, that is elevation in the boiling point. Elevation in boiling point. So that is delta TB. So delta TB, if we go from the scratch, if you understand this from the scratch, delta TB is directly proportional to the molality, right? Delta TB is also is equal to Kb into m. M is the molality. And to be more specific, we write that I is a Vent-Off factor. I is a Vent-Off factor which tells about the association or the dissociation of the particle. Means if I'll tell you the meaning significance of the I is if I is greater than 1. If I is greater than 1 means dissociation takes place. Dissociation takes place. Okay. Means when um, NaCl, when you put the NaCl in water, example will take NaCl in water. What will happen is that this will split as what? Ions. There was one particle. This was one particle of the NaCl. Now it will split as a Na plus and a Cl minus. In aqueous solution, in water, this will be considered as a two particle. So I factor for this NaCl when dissolved in water will be 2. Now this question is different. I'm just telling you the significance of the I. If I is less than 1, if I is less than 1 means association takes place. Sometimes we call that to be a dimerization. Means molecules associate, two molecules associate, right? This is called as a association of the molecule. Associate. They association takes place. A good example for this will be um, you take a carboxylic acid. Let's take this CH3 COOH. This is one carboxylic acid molecule. Another carboxylic acid molecule will be this way. And then there will be a hydrogen bond between this oxygen and hydrogen. So this will be considered as a one particle. This is a dimerization, right? And that time I will be less than 1. Here in this case, I will be half for this. Less than 1 means. And if I is equal to 0 means, if I is equal to 0, if I equals to 0 means there is no dissociation or the association taking place. So I should write over here that no dissociation or association of the molecule. No dissociation or association of molecules takes place. Molecules takes place. Example, when glucose, if you put this C6H12O6, when you put this in water, what you get is glucose solution, right? Glucose solution you will get. Means the ions of this, the atoms of glucose are not going to split. This is one particle, and when it is in the solution, there also it is a one particle, right? So here I will be, it is I, we are told to find what is I, right? So delta TB. What is delta TB? It is delta TB is TB TB minus T naught B. Means this is the boiling point of the solvent. This is T naught B is a boiling point of the solvent. So I should write over separately what is TB. TB is boiling point of solvent. Means without the addition of the non-volatile solute. And this is delta not, sorry, delta B is a boiling point of solution. That will be higher, no? That will be higher. And T naught B is boiling point, boiling point of solvent, right? So, and this is Kb into M into I. So here solvent is water. Solvent is water. Aqueous solution. They have mentioned about aqueous solution. So delta Tb, boiling point of the solvent, we know that it is 100 degrees Celsius. See, this is a difference. So there is no need of conversion, conversion, whether it is a difference is in Kelvin or a degree Celsius, difference will remain same. Okay, 100 degrees Celsius minus 100.18 degrees Celsius. Kb is equal to how much? Kb is given to be 0.512. And the molality. Molality, they have mentioned it is 1 molal. 1 molal means molality is 1. And what is I? So here, this, what I have done. Just a minute. So many mistakes I am making. This is it is this 100.18 minus 100 degrees Celsius. Okay, it is this way. So this is 0.18, which is equal to 0.512 into I. So therefore, I is equal to what? 0.18 divided by 0.512. So here answer will be 0.18 divided by 0.512. Answer comes to be I is equal to 0.351. Means what happens over here? A associations takes place. Means these molecules combine. Next question is this. The molarity of the solution containing 2.44 gram of NaOH in 250 ml of the solution. This capital M over here, this capital M over here represents a molarity. Capital M means molarity. And what are the units of the molarity? Molarity units are moles per liter. Either you can write this or you can write capital M. It is one and same. So, what is molarity? Molarity will use. What is molarity? Molarity M is number of moles of solute upon volume of solution in liter. Okay. So there is a multiplying factor 1000. Sometimes in some of the books it is given 1000. It is a conversion factor. If you are writing this volume directly in ml and that multiply by 1000, that will be liter. If you are first only converting a volume to a liter, there is no need of that 1000 over here. Just understand this. Okay. So how do we calculate a number of moles of solute? Number of moles of solute. This is n, no, and this is volume. I will write V, right? So how do we calculate number of moles of solute? We'll split these terms also. number of moles of solute N is a given weight, given weight upon molar mass or molecular mass or atomic mass. Okay, this way. So over here, what is the number of moles? Given weight is 2.44. Given weight is 2.44 gram. And molar mass of the NaOH. What would be a molar mass of NaOH? NaOH. Sodium is 23, oxygen is 16, and hydrogen is 1. So this comes to 40 grams per mole. This is unit. So I'll write over here 40 grams per mole. This gram and this gram gets cancelled. So here, what would be the answer for this 2.44 divided by 40? So answer is number of moles we are finding. Huh? So as of now, it is 0.061. This per mole will go in the numerator. It will be mole. Now, what would be a molarity? Molarity M will be 0.061. And what is the volume of the solution? They have mentioned that volume of the solution is 250 ml. So you can directly write this to be 250 and you multiply this 1000 over here. Okay, or you can do this way also, or you can write molarity is equal to 0.061 into 250 ml. No, milli means 10 raised to minus 3 liter. Means when this 10 raised to minus 3 go on the top, what will it will be? It will be the same thing, no? So either you convert it first or use this formula of 1000, showing that 1000 it is one and same. So here volume volume was how much? I'll start from the beginning. I'll directly convert this volume. So volume was 250 ml. So 250 ml means M stands for prefix 10 raised multiple 10 raised to minus 3. So I am doing this 250 into 10 raised to minus 3. So this will be 0.061 into 10 raised to power 3 divided by 250. Means over here 1, 2, 3 is 61 divided by 250. 61 divided by 250. So molarity over here comes to be equal to, molarity will be is equal to uh, 0.244 moles per liter. So here is the question. A solution of the organic compound is prepared by dissolving 34.2 gram of it in a 500 gram of water. Here they did not mention what is the like what is that solute. They just said that organic compound which is 34 gram is dissolved in a 500 gram of water. The temperature is 100.104 degrees Celsius of the solution. Means this is the elevation, right? So this is elevation in the boiling point. Coming to the formula directly, delta TB. This is the elevation is directly proportional to the molality, right? So delta TB is equal to Kb molality and into I, right? So here, what is the thing is that we'll consider I to be equal to 1 because it is not mentioned. If they had mentioned about electrolyte solution or they had told the compound, then we will be taking I value. I'll teach you later how to calculate that I also. Like for example, I'll teach you now only. If it is a NaCl, this will split as a Na plus and a Cl minus. So over here, I is equal to 2. If it is MgCl2, if the electrolyte is MgCl2, it will split as Mg2 plus and a 2 Cl minus ion. So I is equal to 3 over here. This 2 ion and this is 3. Uh, K2 or K2 um, or we'll take K2 Cr2O7. Here 2K plus and Cr2O7 2 minus. So this is one ion and this is two ions. So here also I is equal to 3, right? So it's this way. So here we'll consider I to be is equal to 1, assuming that it's not getting dissociated. So I'll just write this to be is equal to 1. I will be is equal to 1. So delta TB is equal to Kb into molality. Now what is molality is equal to? Molality is a number of moles of solute and upon mass of solvent in kg. So this is 1000 is multiplying factor. So what is A over here? We have assumed that A is a solvent. A is solvent and B is solute. Always use this convention. B is a solute. B comes later. No? We put a solute later. That is how you can understand. And we'll write this formula. See, you can directly remember the formula of the elevation in the boiling point, not an issue. You can directly use that. So NB is equal to what? Number of moles of solute. That is equal to WB and MB, right? Weight of the solute upon molar mass of the solute upon WA into 1000, right? So this is my final formula. This is what the final formula, and we can easily use this formula. We can use this formula for calculation of what is asked. So coming back to the question, uh, calculate the molar mass. So what would be a delta TB? Delta TB will be is equal to this. Delta TB over here is TB minus T naught B KB WB, and this is MB, and this is WA, and this is 1000. So 500 gram if you are writing over here. If you're writing this 500 directly as a weight of the solvent, then this 1000. Or you can write directly 0.5 kg also. So TB is what? Boiling point of the solution, that is 100,004 minus boiling point of the solvent alone is 100 degrees Celsius. Water boils at 100 degrees Celsius. KB is given to be 0.52, right? And WB is 34.2 weight of the solute. And molar mass of the solute, that is what we need to find. And this is WA is 500, right? So WA is 500 into 1000, right? So this will get cancelled this way twice. This difference will be 0.104, 0.52, 34.2 MB into 2. So therefore, MB will be is equal to 0.52, 34.2 into 2 divided by 0.104. So we'll solve this 0.52 multiplied by 34.2 multiplied by 2 divided by 0.104. So answer molar mass of this is MB is equal to 342 grams per mole. Uh, so here, yes, this should be the unit over here. Let's see unit also over here, how it gets cancels. Here, this is Kelvin's kilogram per mole, and this unit is Kelvin kilogram per mole. So here, molar mass is asked, right? Unit is grams per mole. This is what we know. Since we know this, we have written it this way. But actually, from here, if I want to calculate, or let's say I want to calculate it um, from here only. Let's do this. So we are focusing on the units. I'll write here. So units MB. What is the unit of this 0.52 Kelvin kilograms per mole? What is the unit of 0.34.2? It is gram. Okay. And what is the unit of this 2? See, this 2 is actually 1 by 0.5. If I am writing this, I will be writing it this way. If I am not writing that 1000, then I shall be writing it to be directly 0.5 kg, right? So 2 is equal to what? 2 is 1 by 0.5, no? 2 is 1 by 0.5. So this 2 could be written. Okay, I was here. Something network problem happened in between. This is I have explained you over here. This is 0.5 kg, right? So this instead of writing this 2, what I do is I will write 0.5 kg, right? So this is Kelvin kilograms per mole for this 0.5 to 34.2 is gram, and down it is 0.104. So it is degrees Celsius. Even if you convert this to a Kelvin, difference will be in a, you can directly write, since this is a difference, it is in degrees Celsius, you can directly write this to be in Kelvin only. Okay, difference will be same, and this is kg, 0.5 kg. So this Kelvin, what remains is grams per mole. So that's the unit.